Today we'll build an AI agent, or we'll dive a little bit deeper and we'll take a look at what actually happens inside of an AI agent, how it works internally, because we'll build it with code. We'll not use tools like N8N, which, by the way, is an amazing tool, just to say that already. So N8N is a really great tool for building all kinds of workflows, including workflows that use AI in a visual way, so without writing code. And I do use that tool in my course as well. And in case you haven't heard, of course, I gotta advertise this latest big update, which I pushed out for this course. So give me a second. I got this course here, this ChatGPT and generative AI course. I released it together with Manuel, my colleague, 2 years ago, and we updated it since. And I released a huge update a few days ago. And in that course, we now also cover AI agents, also with tools like N8N, as I just mentioned. So there you also see the no-code approach. And there's a bunch of other amazing stuff in there as well. So that might be interesting. And you can get it by simply visiting acad.link/chatgpt. So that's just a side note, though today is not about this course. It's about building AI agents with large language models in general. And then we'll also try to build one that runs locally on our machine with Ollama. And Ollama, of course, in case you have not watched last week's stream and you haven't heard about it in any other way, Ollama is an amazing tool that allows you to run open large language models like the Gemma models by Google, the Qwen models by Alibaba, the DeepSeek models, and so on your system. So you can run these models on your system so that no data leaves your system. You don't have to pay for OpenAI and all that fun stuff. However, we'll actually get started with building AI agents by using the OpenAI API because it's particularly easy to build agents with that. And it's not just OpenAI, it's also other providers like Google Gemini and so on. But I'll use OpenAI as a start, and then later, if we got time, we'll move on to Ollama. Now, what's important is that we have a good understanding of how AI agents work or what's actually going on under the hood. So we'll start with a bit of theory here because that is important. We gotta understand how they work, and we gotta understand in general how exactly large language models like the ones that are being used by OpenAI or that are available through OpenAI, how they actually use tools, because that is an important aspect. Because an agent, in the end, as we define it today, is in the end a large language model, right? So it's a large language model plus tools. In a nutshell, that is an AI agent, right? Now, of course, it's then an agent because the idea is that it will actually choose on its own which tools to use under which circumstances. So it should be smart about the tool choice. It should make that tool choice on its own so that we can, for example, ask a question. So we could have a prompt that is something like, what's the weather in San Francisco? So that could be our prompt, right? And then, depending on which tools this agent has available, it may be able to answer this. Now, without tools, it's not able to answer this because the large language model, of course, was trained on some training data that probably contained information about the weather in San Francisco a year ago on a specific day, but not today's weather. It can't know that. It doesn't have access to live data. That changes when we add tools, though. And of course, when you use ChatGPT, so here I'm logged in my account, when you use that, we also got tools there, right? We got the search tool, for example. We can enable that to kind of force ChatGPT to use it and search the web. So if I ask it, what's the weather in San Francisco, and I enable search, it will search the web and it will therefore probably find some source that tells it today's weather. So yeah, I am not in San Francisco, but let's say this is correct for this week. Now, actually, the way ChatGPT and most other chatbots work is if I ask a question like this, like what's the weather? And now let's say in Munich, because that is where I do live. And I say today, typically they will detect questions like this and search the web even if you did not explicitly enable that tool. So still it's searching the web and I can tell you this is correct. But they do need tools in order to complete tasks like this. That's important. And of course, you might want to build some application, some AI agent that can do more than just search the web, because you could use OpenAI, you could use ChatGPT for that. Or even then, you might want to build your own agent because you want to search the web in a certain way, you want to filter out certain results, you want to do something special with the search results. There are many good reasons for building some smart AI system. And I guess that's also important. AI agents are kind of a buzzword, they're everywhere. And an AI agent can be as simple as some application that can use tools, and it can be as complex as some application that can use plenty of tools and maybe also communicate with other agents. So where other agents also become tools, though at least in my experience, I'm not sure if we really have useful, super powerful AI agents yet. Anyways, that's not the matter today. We will focus on how we can expose tools to large language models, how that works under the hood, and therefore we can build our own basic agent. That's the idea. And here it's important to understand that the large language model, this thing here, never, under no circumstances, uses the tools itself. Instead, what actually happens is that you're using that large language model, ChatGPT, not ChatGPT, the GPT models that are used by ChatGPT or the Gemini models that are used by Google Gemini. You're using them inside of some application. And that application could, for example, be ChatGPT. So ChatGPT is an application. It's an application built by OpenAI. So that is something to keep in mind. ChatGPT is an application, it's not a model. But in that application, we of course have a model. In that application, we have our large language model. And in case of ChatGPT, that could be something like the O3 mini model or any other model. They do have a bunch of models, of course. So that's the model in the application. Why is this important? Because this application contains a couple of other things as well. For example, this application contains a list of tool definitions. Or not just definitions, it contains the actual tools. And what are tools? Tools are just functions, simple functions defined in code by the OpenAI developers or the Google developers, or by you if you're building your own agent. So we have these functions here in that application or on the same server where this application runs. Of course, the exact architecture depends on the application and so on, but these are simply code functions that are somewhere on the servers of OpenAI, for example. So that's important to understand. That's part of the application, but not part of the large language model. Instead, what happens here is that these tool definitions are exposed to that model. So they are sent to the model in a prompt in the end. You can think of this exposure as an invisible message that's inserted in the chat history, because that's something else we got in this application. We got our chat history, right? Because if we're talking about ChatGPT, then of course we have an application that's all about some chat, some AI-driven chat. And of course, therefore, we manage this chat history, or OpenAI manages that chat history on their servers for us. And this chat history is sent to the large language model with every new prompt we add, right? So if we have a prompt, so our prompt, like, what's the weather? If we have something like this, then this prompt in the end makes it into this chat history, and that chat history combined with all the older messages is then sent to the large language model. And the tools are actually also sent to that chat history. They're inserted there as a invisible message, you could say, and you'll see how that works a little bit later. We'll get there in this stream. So we got these tools here, these functions, and they are in the end the definitions of these functions, not the functions themselves, but the definitions are inserted into that chat history. And then that chat history is sent to the large language model. And if we now have a prompt that makes it likely that some tool could help with answering that prompt based on the function definitions that were inserted in the chat, then this large language model is likely, not guaranteed, but likely to output tokens, because it is a token generator. That is what a large language model is in the end. It's likely to output tokens that describe the intended use of some tool. So I know this gets complex, but you'll see it in action later, but I think this theory makes sense here. What this large language model outputs in the end, and it does that internally inside of that application first, what it outputs is in the end, whoops, let me move that down, is in the end a response that we don't see as the user of ChatGPT, but that's instead first handled internally inside of the ChatGPT application. And that is the response that may contain some intended tool use. So it might tell us that it wants to use some tool based on the definitions that were exposed through the chat history. And then the application, which again is an application written by the OpenAI developers, for example, that application has to translate that intended tool use into an actual execution of one of the functions that were defined by the OpenAI developers or any other developers. So the code gets executed inside of that application on the servers of OpenAI by that ChatGPT application, for example, not by the large language model. The large language model only describes its intent to have some function be executed, some tool be used, but it's the application that then executes the code. And you'll see that later once we get there. By the way, I just saw that the prompt is not visible, so let me change that. So that is how that all works in the end, right? So that is how you can think of this, how an AI agent works, what the idea is, and now we're going to build this to make it a little bit clearer, hopefully. And again, I'll start by using OpenAI, the OpenAI API, and then we'll move on to Ollama later. Now for that, I created a Python project here because Python is a good choice for playing around with AI using things like the OpenAI SDK is quite straightforward there. So I created a new Python project using UV, which is a Python package manager, a relatively new one, which is amazing. And in here, I will now add the OpenAI SDK. We could also directly reach out to the OpenAI API, but here I'll use the SDK. So therefore, from OpenAI, I'll import OpenAI, and I'll create a new OpenAI client. And I will need to use my OpenAI API key. So what I'll also do is I'll add the .env package to call the load.env so that I can add a .env file and set up my OpenAI API key here. And of course, I'll not show that on stream, so I'll quickly do that off screen or outside of this window. So give me a second, because of course, right now I have to log in. So let's log in. Great, let's go to the dashboard. Let's create a new API key. Here we go. And then on another screen, I'll quickly insert it into my .env file. What's going on here? Why does this not work? Here we go. And make sure it's not visible here. It isn't. Awesome. Okay, so now I have this in my .env file, and of course I don't want to include that on Git, so I'll git ignore it. And now that should be available, and we should be able to use that OpenAI SDK here. So what I want to do here is, in the end, just copy this code, and then I'll explain it step by step and explain what's going on here. Actually, the tool definitions can be moved out of there, but that's not too important. Fix the indentation. Also here. Okay. And let's quickly see if that works. So I'm now sending this prompt, which is hard-coded into the application, to OpenAI. And you can see I got back a result that is a function tool call where it looked up the location Paris, France, because that is what I'm asking for here in this hard-coded prompt. And it called a function called getWeather. And then I don't think the result is included here, right? So we would probably need the output text here. Let's try that again. Oh, right, no, my mistake. We're not handling the result. We'll do that soon. So it did call, you can see that, it did call a function called getWeather, or there is something going on related to that. And where is this coming from? That's coming from this tool definition here. Because as I just explained a few minutes ago, the large language models themselves don't call the tools, they don't execute the code. Instead, they run in an environment, in an application shell that is able to execute code. But the large language models only create tokens, only generate tokens that describe an intended tool use. And that's what's going on here. What we get here, this output, which we get back from the large language model, or from the OpenAI SDK actually. This is the translated response of the large language model translated by the OpenAI SDK, or the OpenAI servers and the SDK to be precise. And it's the translated response that describes the intent to use a tool. Because in there, and that's simply following a certain format that has been defined by OpenAI for their API. In there, we get the name of the function it wants to execute and the arguments that should be passed to that function. And now it's our job as the developer of this application to perform the actual tool call. So here it did not call any tool yet. It's just the intent. This here is just the intent. No code was executed yet. Instead, now it would be our job to do that. Before we do that, though, let's understand how it knows about the available tools. Well, that happens because we're passing this tools value here to the OpenAI SDK when we create a new response. And that's simply how the OpenAI SDK works. It supports that tools feature, and the OpenAI API that's used by the SDK under the hood also supports this tools feature. So you need to be working with some API, some SDK that supports the concept of having tools. And we'll see how it could work in a different environment later. But that is something that's provided by the OpenAI SDK. Now, what we pass to tools is a list that contains dictionaries, or in this case, one dictionary. And it contains one dictionary per tool that we want to describe to the API or to the large language model specifically. So here it is only one tool which we have in this application, so it's only one dictionary. And here we say that it is of type function, and in case of OpenAI, it always must be of type function. There is no other possible value here, at least right now. Then you have the name of the function, and this is totally up to you because you're the creator of this application. You can call your tools whatever you want. Here it's called getWeather. Then you describe what the tool does, and that's important because that tells the large language model when it might want to call this tool. And of course, just because it's important, the large language model doesn't really have intelligence. It doesn't really understand what you're saying here, but it's all about generating tokens. And by having this description here, the large language model is more likely to generate tokens that describe the intent to call this getWeather function if you have a question related to weather-specific concepts like temperature or other weather conditions. So this description here is important. And then you describe your parameters, so the input values your function, your tool requires. You don't have to accept parameters, but most tools probably do need some parameters. And this is then again a nested dictionary of type object, where you then have your actual parameters defined as properties. So in this case, there is a location parameter, which is also required, that is wanted by this getWeather tool. And that should be some text. And simply, again, you have a description telling the large language model which kind of text it should be. So in this case, that we want the city or country for which we want to get the weather. That is the definition of one of our tools for the large language model. Again, what's not happening here is that any code would be executed, because this entire code here, this application is of course really simple, and in there is no code that would do something weather related. That's instead what we will have to do. Actually here, I will switch to GPT-4o for now, but the other model should have worked or will work too. Okay, Alberto, hello Max, this is a very interesting practical use of AI. Thank you for showing this to us. I won't be able to stay, it's working hours in the Americas. I will definitely watch the video later. Yeah, thank you so much, Alberto. Thank you so much for tuning in again. I know you've tuned in past streams as well. And of course, you already know probably, but in case others are watching and also won't be able to stay around for the entire stream, you can visit youtube.com/Maximilian-extended, and I upload all my live stream VODs to that channel. This one will also be there tomorrow, so you can watch or rewatch it there. So, and now that we got this out of the way, we have to define a function that will actually be that tool that should be used. So I'll do that here. And I just copied this here from this OpenAI example. Of course, you could build any tool, any function that does anything you want to do. In this case, there is a getWeather function. And the idea is that this getWeather function here will be executed by your code if the large language model wants it. So here I'll adjust this function and actually take a location, which should be a string. And I will not send an HTTP request to a third-party API, which this example here does, and which you could do in your tools. You can do whatever you want. You can send a request to another API. You can create an email and send an email. You can do whatever you want to do in your code. Here for this demo, I'll keep it super simple, and I'll just set up a dictionary called locations, which contains exactly two locations. Munich, and for Munich, I want to have a dictionary that describes the weather. So we'll have a temperature, and then, yeah, sure, let's go with these suggestions. And then I also have Paris. That's what Cursor decided here. So this is some basic made up dummy weather data. And of course, you could add more, right? So you could, for example, also add something like clouds. And have some percentage of the sky that is covered by clouds or something like this. And then here in locations, I want to check if the location I receive here is not in locations. In that case, this function will return, sorry, I don't know the weather. And otherwise, it will return the detailed weather data for that location. And of course, for this dummy example, there are only 2 locations, but it's just there to understand how calling tools works. Therefore, I will also adjust this definition, because now it's actually the temperature for a given city, because I only have cities in there and only 2. So here I'll say city, makes more sense. And then here it's also a city and city and city. And I guess it makes sense to name this here cities, since it's just that. And then here I'll say for the description, the city to get the weather for, to be very descriptive about what this tool can do and what it can't do. So now we have the definition and we have the actual code. Now we need to execute that code based on this response output. And let's see if the official example here also shows us how that works. Otherwise, I will do it. But no, here we got exactly what we need. In this response output thing here, which we get back from the SDK, we actually got a list. And for now, we can just assume that the first item in the list is the latest reply we got by the API, by the large language model. And in there, we'll have this, well, I guess I can print it. We'll have this tool call description, this response function tool call thing here. So actually, what we want to do is we want to parse that. And I'm not sure. I think there should be a tool calls property in there, but we can simply check that. So Paris is, of course, one city that we have in there. So if I run this again, it should again try to execute a tool, but now I get an error. What's the error? An error occurred. Yeah, please include, what's that? What is the actual problem here? I mean, it worked a second ago. It didn't really change anything about the logic here. Is it not happy with me using GPT-4o? I mean, sure, we can use 4.1, I don't care. An error occurred whilst processing this request. That makes no sense, because I did not change anything about this code. So sending this to OpenAI should still work. So why is it complaining? Let me quickly check. It's of course the typical thing to happen on a live stream. You test it all day and it works, and then it breaks. Well, I'll try again later. For now, I'll just continue with what we would do. So we got our response output. And the idea now is that we got a bunch of potential tool calls in there. So in the end, and that's the thing I can't show right now, this thing here, the first element we got in this response, could describe a tool call. It could also be the text that's intended to be shown to the user. we don't know yet. So we might want to call it result. And then we might want to check if it is a tool call or not. Now, it would again be really interesting to see how it looks like. And for that, it would be helpful if sending that request would work and if it would not keep on crashing. But it does. Great. I mean, it's a 500 error, so it's a server error. It's not a client error. It's not that I'm sending wrong data, as it seems. It really seems to be a problem with the OpenAI servers. So I guess I'll switch to local models a bit earlier than intended. Now, what we would do in theory here is we would check this output. And give me a second. Give me a second. So what we would do is we got our output, right? We got the first result here. We would check if the output here has a type that's equal to function call, because in case of OpenAI, that is what we would get if this is a response by the large language model that communicates the intent to call a function. Am I still online? That's the question. Because I seem to have some network issues here. No, I think it's working. Here in my software, it's showing offline and online, and it's kind of switching. But I guess I am online. Okay, sorry. So what we would get back by OpenAI is this output thing, which has a type property, which might be function call if the large language model communicated the intent to call a function, to use a tool. And in that case, in there, we could get the tool name by accessing output.name. We could get the arguments, the tool args, by accessing output arguments, though output arguments will actually be a string because it's in JSON format. So we would have to do JSON loads like this and import JSON, which is built into Python, to convert this JSON string, this JSON text to a dictionary. So, and then tool args would be a dictionary in the end, which in our case here, since we only have one tool that could be called, would be a dictionary that should have a city key. So we should have the city, which we can access by using tool args city. Now, in theory, we should also check if tool name is getWeather and only execute this code if it is, and otherwise we could return an error and print unknown tool. So then here we call getWeather, and that's the important part. We call getWeather in our code. It's not the large language model. We do that. We call getWeather because we know that the large language model wants to use a tool named getWeather, and we call it with the argument that is also provided by the large language model. And then we have the result, and we can do with it whatever we want. And here I'll just print it later. We'll also do something else with it. Otherwise, I print unknown tool. And if the large language model does not want to use a tool, which is also possible if we send a prompt to it that does not require a tool call, in that case, we'll just output the content of the result that's sent back by the large language model. Because if the type of the output we get is not function call, then it is, in our case here, simply the text that's meant to be sent by the user. So in that case, I just output that text. That's what I'm doing here. Now let me try again. Let's see. Does this still keep on crashing? It does. That is super annoying. I might have some weird error in there, but it is a server error, right? So not much I can do, I guess. So what I'll do is I'll try again later. For now, I'll leave it like this, because that is how we would handle a tool call when using OpenAI. And that is in the end how it always works, no matter if you're using OpenAI models or Google models or other models. You describe the tools to the large language model then describes an intent if it makes sense, and then it's your job in your code to translate that intent into actual code execution, which is what we're doing here. We're then calling getWeather if the large language model wants us to. And then we can do with the result whatever we want. Here, I'm printing it. Alternatively, we could, of course, also be managing a chat history here. And we could merge that result of that tool call into the chat history. So we could do something like that as well. So what we could do is we could basically get the user input, where we ask for the prompt, and then we check if the user input is exit maybe, then we return so that we can close the chat. Then we append that with the role user, and then we send this history as an input. But of course, in that history, we also want to include that result. And by the way, that of course should be in a while loop here. All of that. So then we have that user message in there. Then we communicate with the large language model. We get back a response which contains some output. And then it depends on what happens. If we don't have a tool call, so if we make it in here, then I don't want to, well, I do want to print output content, but I then also want to append that result to the chat history, but now with role assistant, because this here is the response sent back by the assistant. If, on the other hand, we have a tool call, then I want to append another element to the history, which could be of role assistant, where we set the content to you wanted to use the getWeather tool, and actually we should not hard code this, but instead we could say you wanted to know or to use the tool, and then here this should be the tool name with the argument, and then in this case here that's the city. And I will actually not include the result here, just the description of what the assistant wanted to do. Because then I could add a new message here, and that could again be the user. And there we could construct a prompt where we say the original question was, and then I want the user input, so the original prompt. You called, or you wanted to use a tool, and then the result of the tool use is, and then we could include weather here. And weather is simply the result of calling getWeather. So that would be one way of injecting the description of what happened into the chat history. Because again, it's us managing that application. So we have to provide all these details to the large language model so that it can use them and so that it can construct meaningful responses. So now we would enrich the chat history with its original request that it wanted to use a tool and with the result of that tool use, like this. And then here we would return or we would want to again reach out to the AI, to be precise. We would want to send another request with the updated chat history. So actually what I'll do is I'll generate a new function here, generate response, where we pass in the history and where we communicate with the model and where we return the response output, the first element, let's say. And of course, I want to call that here. So instead of that, I call generate history, and I want to do the same here, generate history. But now the output here should be the final result. And we could make this a bit more elaborate to allow for multiple tool usages that come after each other. So you might want to restructure that, and that is something I do in that full course. But to keep it simple and avoid recursion or complex loops here, I'll just call generate response one more time. And now here we will get the final response. So here I will then again append to my history the final response. And of course, I also want to print that like this. If we get an unknown tool, we could also handle this with similar code where we could say you wanted to use the tool. So something, you wanted to use a tool, this tool doesn't exist. And then again, we could generate a new response and output that. Again, that's not the most flexible way of doing it because it only allows for one tool use, but it would be a way, a basic way of getting started. So now it's a pity that this doesn't work, but we'll therefore move on to the local models. Yeah. So I'll save this, OpenAI, create a new main.py file, and in there start from scratch using Ollama. So I already mentioned it, Ollama is a piece of software you can install on your system to run models, large language models on your system. And I already got it installed. And the great thing about Ollama is that it also comes with a server, which it runs automatically on your system. And on that server, or through that server, you can use Ollama programmatically. Because normally when you install and use Ollama, or when you get started with Ollama, you typically do that through the command line. So what you can do with Ollama is you can run Ollama run, and then what was the model name? Ollama ls. You can run Ollama run, and then your model name, like the Gemma 3 model here. And then you can send your prompt here in the command line. So now it starts up, loads the model into memory, which can take a while. And then I can ask, what can you do for me? And now I'm chatting with that Gemma model that's running on my system through Ollama. So that's now not being sent to some API, that's happening on my system. But Ollama exposes an API, a little server that's running on my machine, and we can communicate with that locally running API to use Ollama locally. And the great thing about this API is that it also supports tools for the model that is being used if that model supports it. So let's add a generate response function here, and I'll name it, I'll just pass in a prompt for now. And in there, I want to use Ollama, so I will send a request manually. So I'll use the requests package, which is provided by Python. And here we can now send a post request to /API chat. So it's requests post, and then Ollama runs on localhost 11.434, if I'm not mistaken. We can send a message to API chat. And actually, let's pass in the history. Why not? And to this endpoint here, we should send a model parameter, a messages parameter, and then if we want to use tools, also a tools parameter. So we have model and messages. Stream should be set to false. That's correct because I don't want to implement streaming here. The model is not GPT 4.1 though, but instead it's Gemma 3, 12BITQAT. That is this model here, which I downloaded to my system. And that's an open model. So that's the model I want to use. I pass the history to it, and that allows me to set up the history here, set up a chat, ask for user input, check if it's exit, return if it is, append that message with role user to the chat history, generate an output, print the output, and execute that code. So that's what we can do here. And that should now work since it's running locally. So if I do that, what can you do for me? And that will take a while because I'm now not streaming the response. Instead, I'm waiting for it. So it can take a while for it to arrive because it's now only coming back in one block instead of being streamed in token by token. So let's wait for that to arrive. And whilst we're waiting for that, I can already say that Gemma is actually not a model that has built-in tool use from Ollama's perspective. You can tell by the fact that on the Ollama website, if you go to models, you can inspect the different models, and you'll see these tags here. And these are simply the different sizes of the model that are available, the different parameter sizes. But then here, for example, the Gemma model has vision capabilities, which means you can send images to it and it can see those images. But there also are models like the Qwen model, which have a tool flag. That means this model can use tools when using it through the Ollama API. So that tools parameter here can actually only be set to a value and is then understood by Ollama if you have a model that supports it, like the Qwen 3 model. We can give that a try later too. But for now, I just want to show you that this works. What can you do for me, Non? Thank you very much. So I guess I parsed the result incorrectly. We get back a response that has this format. Model, we were looking for the message content. I am accessing generate response history. Well, I'm not returning anything. That's the problem. So that was a good start. I'll send a shorter prompt to hopefully get back a shorter response, which is a bit quicker. Yeah. So now I got back a response, which is a dictionary where you can also see that content here. That's the content that was generated. So I could access the message key and then the content key to output this. Output message, output message content like this. And now if we try this again, hi, I should get back, yeah, the text. So that's working. Now for the tool use. The great thing is we can set this tools parameter, but only if a model supports it. So let's use a model that does support it. And for that, I first of all have to download this Qwen 3 model, and I'll use a small one so that the download is relatively quick. I should have done that before, but I will do it now. So Ollama pull Qwen 3, and I will just use the 1.7 billion parameters model here. So now that should be relatively fast to download. And I hope my stream doesn't go down whilst I am downloading it. And this should be a model that does support tools. Now we can already get started with the definition here for the tools. And do they have a dedicated... No. List of tools in JSON for the model to be supported. Let's see, do they have some example? Yeah, they do have an example here, how that should look like. So in case of OLAMA, again, just as before, we have a list full of dictionaries, one dictionary per tool, just as before. The type must be function. And then you have a function key, and in there a nested dictionary that describes that function. So in this case, again, we could call it get weather to get the current weather for a location or for a city in my case here. And then we got parameters, which is of type object. And then in there we got our city parameter, let's say. And that's actually all I want to have. So the city should be a string, and it's the city to get the weather for. For example, Paris. And that is required. So it's exactly the same shape, or pretty similar to what we saw before. That hasn't changed. What also doesn't change is that we have to define the code. So get weather, city, and then we could try to send a request to some API that gives us that weather. What I'll do instead is I'll just copy get weather from here so that we see how that should have worked in theory, so that we can get some made up weather for Munich and Paris. And then we can see that if we are providing tools to the model and we have a model that supports it, then we might get back a response that actually contains a tool calls key in that message. So the content then is empty, the text that's generated by the model, and instead we have tool calls. And that will then be a list of all the tools it wants to use. So what we should do here is we should check if output has a tool calls key, because again, that means that we want to use a tool. And maybe also if the length of output tool calls is greater than 0, so that we have at least one tool call. And then we can get access to that tool call description, and that will be a dictionary in OLAMA's case that has a function key, as it seems, and that has a nested dictionary, and in there we find information about the name of the function it wants to call and the arguments. So then we can access the tool name and the tool arguments by accessing this function key. So function and the name and arguments, that is what we're accessing here. And then we check if the tool call is get weather, and if it is, we again use our arguments. And I'm not sure if we need to parse this as JSON. I don't think it is in JSON format. So actually, we might already be able to use tool_arg city, but we'll see whether that works. And then, very important, we call the code. Again, it's us that's calling the code. And then we append that to the chat history. However, not with the role of tool, but instead as, well, you can do it in different ways. What I like to do typically is that I add an assistant message where I say, you wanted, or I want to call the tool, and then I got my tool name with the arguments, whatever. And then I append a user message, a made up one, which wasn't actually sent by the user, where I sent my original prompt was user input. You wanted to use the tool with the arguments, whatever. And then I say the result of the tool call is something. To make that a bit easier to read, I'll split that across multiple lines here real quick. So let me quickly do that. Also split that string across multiple lines so that this is the augmented prompt I'm sending to the large language model. So I have an assistant prompt, which is just what it wanted to do. And then I have a made up user prompt, which contains the original user prompt, but also a description of what happened, and most importantly, the result of calling that tool, which in this case is that weather data. And actually that weather data, of course, will be some dictionary, so I want to convert that to a string by converting it to JSON, so that it's technically a string, which I can inject here. And then this is also part of the history. And then we need to generate a new response, which has this updated history, which includes the tool call information. Whoops. So now I can again generate a response and then finally output the message content, which is either some text right from the start, or if we had a tool call, it is some text that's based on that tool call, because we made it through all these if statements here. That is the idea here. And again, that's not the perfect code here. It only allows for one tool call, but it should do the job if we have a model that supports tool calls. So let's see, Qwen 3 was downloaded. So we'll now try this code with that model. So instead of Gemma, I will use the Qwen 3 1.7, was it right? Yeah, 1.7 billion parameters model. So it's a very small one, not too capable, but let's see whether it works. Why is history not accessed? I am using it here. What's the problem here? It's not closed. Oh, I think I deleted. Am I not closing some string somewhere? No, that looks good. So what's the problem here? Where am I not closing this? I am closing this. Oh, the comma is missing. Okay. So now with that, I think, by the way, I'm not seeing chat messages in my system here. Well, anyways. So now with that, let's see if that works. UV run main py. If I just send hi, it should not try to call a tool. Key error tool calls. So I guess I'm getting this because I'm accessing this. So we should actually check if that key exists here. Because it will only exist if a tool was called. And then you see here, in case of Qwen, it's a thinking model. So we got some thinking part, and then we get the actual response. Now let's try something that should trigger a tool call. What's the weather in, which cities do I support? Munich and Paris. In Munich. Okay, nothing happened here. What's wrong? By the way, I want a log here so that I see when the tool is getting called, and I want to see if that's happening. Yeah. If I could write, what's the weather in Munich? Okay, so it's not even trying to call that. Am I not making it in here? Let's do good old print debugging. What's the weather in Munich? Okay, so I'm not even making it in here. Where is this going wrong? What's in the output here? What's the weather in Munich? Because clearly it worked before for the non-tool calling response. Okay, so what I can see here is in the message, we have a tool calls key, and it does contain a list where it wants to call get weather. So that is working. So why is that not triggering here? Tool calls and output. That's false. But there is a tool calls key here. That is kind of weird. Message. Oh, it's in message, not in output. Yeah. Okay, so we want to check if it's in output message. Yeah, we have to access the message. In there, we find the tool call. I mean, I guess that's what we see in the official docs too. Okay, so that should be the problem here. So now, let's try again. What's the weather in Munich? You see it calls the get weather tool, or it wants to call it. Our code executes it. So getting weather from Munich, that is this statement here. So our code executed. And then here you see that's the thought process it goes through. And the information it outputs here is, of course, the information, the dummy information we set up here. And that was based on the chat history we enriched with the tool call results. And that's how tool calls work. Now, of course, is this an AI agent? That's up for you to judge. It could be a weather agent. I mean, here it's just dummy data, but you could be communicating with some third-party weather API that provides all kinds of weather data that you can then integrate into your application. And of course, you can also add more tools. And that is what I want to do here. So I want to add another tool here, and I'll name it convert temperature. And for that, I want to get the temperature, and I want to get the unit, or the unit and the target unit. And then I want to check if unit is Celsius and target unit is Fahrenheit. I do this conversion, otherwise I do it the other way around. And else, if the units are equal, I return the unchanged temperature. So we got a second tool now. We can also make temperature a bit more precise here, but that doesn't matter too much. So now we got a second tool. Now I want to make that tool available. So therefore I need to add it to my tool definitions up here, because if I don't add it here, the large language model will not know about it, and then it can't use it. So I add another dictionary to my tools list here. And I guess I added it in the wrong place. Well, no. Oh, it was just not finished generating. Let's see if cursor did a good job. Type function, that is what it should be. Function name convert temperature, converts a temperature from one unit to another. Supports Fahrenheit and Celsius. And then we describe the input parameters, that we have a temperature, a unit, and a target unit parameter. That is exactly what I have here. And of course, your description must be in line with your code, because if you're describing a tool that doesn't exist in that way you describe it, then the model may request to use that tool, but your code won't be able to do it as the model thinks it does it, right? So the description of the tool you give to the model has to be in line with your actual code that powers the tool. So you have to have the same parameters, for example. So temperature unit, target unit, that all looks good. Now what we should add here, however, is a short description. The description helps the unit, helps the model use that tool correctly. I guess for these names, in conjunction with the overall tool description, you might not need a description for the individual parameters, but it also doesn't hurt to be very clear of what each parameter is about. So now we got a second tool. We added it to our tools definition, and keep in mind, this tools definition here is something we're passing to the model with every request we're sending to it, with every request we're sending to the locally running model. So that's all in there. So now it could use that tool. Now, of course, we'll now need to change our code a little bit, because now it's not just about using one tool once. Instead, it's now about using multiple tools potentially. So I will actually take this if statement here and cut it and move that into generate response, where I'm talking to that model, right? So I get a response here. I got my output here. Please let me edit it. My output here. And then I got this if check here, because now I don't want to immediately return the output. Instead, I want to check what's in the output. I want to check my tool calls, or if there are tool calls in there, for example. I also will edit generate response here, and not just accept the overall history, but also the user prompt for this specific cycle we're going through right now. And a cycle might consist of multiple tool calls now. So I got the overall history, which could contain multiple cycles, and then the user prompt for the current cycle in the end. And then down here, I again check if we have a tool call. And in that case, I get the tool name and the arguments. And then I want to check if the tool name is weather or get weather. In that case, I get my city argument and I call weather, I convert the result to JSON, and then I update my history. However, that's now not the only tool I might want to call. So actually, I'll change the indentation here and I'll show you why in a second. Because I also want to check that maybe if the tool name is not get weather, maybe it's convert temperature, because that's now another tool I got. So in that case, I want to extract these arguments. And then I want to get my converted temperature by calling convert temperature with those input arguments, which are extracted from the response that was generated by the large language model. And then I want to inject that into the chat history. Now, I will update the chat history either way after going through these checks here. By the way, actually here, we might want to use an if-else if statement. And there also are other ways of writing this, including some more elegant ways, but I'll do it like this. And here I'll add a tool result that is equal no result invalid tool. And here I'll name my result, my weather result, and the converted temperature is now also called tool result, I mean. So I always have a tool result, no matter which tool gets called. And even if no valid tool was called because the large language model requested a tool that doesn't exist, even then I have a tool result. It's just no result invalid tool. And therefore we could, of course, also, instead of an else case, set that as a default and then update it to an actual tool result if we have a valid tool call. And then I'll update my chat history and say, I want to call the tool name with the arguments. And then I have the other entry, the updated or the faked user entry, so to say, where I say my original prompt was user prompt. So that's why I'm receiving that as an input parameter here, because I need access to that to update that history. You wanted to use the tool, blah, blah, blah. The result of the tool call is, and then we have the tool result. So now this is a bit more generic. And now things become interesting. Here I am in that if statement where I know that the large language model wanted to use a tool. So I definitely want to generate a new response with the result of the tool call. So that's what I'm doing here. And I will actually return that here. Otherwise, if I don't even make it into this if check here, I want to return output and then it's message content. So then I want to return the text content that was produced by that model. But if I do make it into this if check here, then I want to call all these tools and then recursively call that function again to now produce the final output. And then I return that. That's my idea here. And yep, thank you, cursor. I need to pass the user prompt into that. And now this is a bit more flexible. Still, there would be more elegant ways of writing this, but it should do the job here. And now in my main function, I call generate response. I need to pass the user input along with the history. And yes, the user input is in the history, but we could have a longer chat with multiple different cycles that have different starting prompts. So we can't just always take the first message of the history and assume that this is the latest user input. That's why I'm passing this as a separate parameter to generate response. And then I print the output here. And now the idea is that we hopefully can get the model to use multiple tools. Now to see whether that works, I will also add a little print message here, converting temperature, so that we can see when that tool gets called. And then again, we can run this and say, so if I just write hi, it should not call any tool at all. And it doesn't. There is no log from any tool function. If I ask, what's the weather in Munich, then it should call this get weather tool. Get the weather for Munich and output that information. Now here for Munich, the temperature is in degrees Celsius. Whoops, that was the wrong key. So if I now ask it, what's the temperature in Munich in Fahrenheit, it should hopefully call both tools. So it calls the get weather tool, gets the weather for Munich, and then it calls the convert temperature tool, converts the temperature, and then it gives me that temperature in Fahrenheit. And that's now a bit more agentic, because now we have two tools that we provide to that model. And again, you could definitely change that code. You could make it a bit more flexible. I deliberately have this code, which hopefully is a bit more descriptive of what's going on. But that is in the end how large language models call tools and how you could build an AI agent. Now, of course, AI agent sounds way more fancy than saying a bunch of code that connects the output of large language models to functions in your code. But in the end, this is an agent. It is a large language model that can use tools to do smart stuff, depending on what you ask it to do. For example, I could, of course, also, just to make that really clear, I cannot just ask about the temperature in Munich and Fahrenheit. I can also ask, what's 0 degrees Celsius in Fahrenheit? And now it should just use the Fahrenheit, just the conversion tool, I mean. And it tells me that this is 32 degrees. So that is tool use. Volkov, what will happen if you use role tool? It simply appends in chat or large language model will generate answer. So I think, I'm not sure if role tool really exists, to be honest. I don't think it does here in Ollama. If I search for it on this page, there is role user, but there isn't role tool. I think this was a hallucination by the large language model. Oh no, it can be tool. It can be tool. Well, good question. Let's give it a try. It's possible, that this manual work I'm doing here is not required if you use role tool. So let's try this. Let's say we now add, that's a great question, thank you. Let's now say we append a new message here where we set the role to tool. Now, I'm not sure how the message should be shaped if the role is tool. Whoops. I'm not sure. Does OpenAI support this? I'm not sure if they do. And in the Ollama documentation, they unfortunately don't tell me. Well, I guess the message is always formatted in the same way, though. So I guess what we do is we set the content to something like tool called, and then we have the tool name with arguments, and then maybe we have something like result, tool result, and now we don't have to do that. So maybe I can save that hassle. So that might be the thing. Let's see if that works. Now with role tool. It's worth noting that this is not always supported though, because as I just showed you, OpenAI does not seem to support this role, which is why you might then need to manually update the history such that the large language model is aware of what happened, which is what I showed you. But let's see whether this here works. So if I ask for what's the weather in Munich, it calls that tool. Now let's see if it understands the result. It does. Okay, so that's a more elegant way of doing it then. Thank you very much. Great question. This here is the more complicated way, I guess. That's how you can do it manually. And that shows you really well what you could do to essentially just update the chat history, because all you're doing with these AI agents or with these AI-powered applications, all you're doing all the time is invisibly behind the scenes updating prompts. That's all you're doing all the time. So last week when we streamed, we did RAG. We built a RAG workflow, and there we also injected data into the prompt. Here, we're injecting information about the tool calls into the chat history, and it turns out that when using Ollama, we can use this tool role to make that even easier. And it's probably not just Ollama. I can imagine that other proprietary large language model providers like maybe Google Gemini, I haven't tried it there, they also might support that role to make it a bit easier to tell the large language model that some tool was used and that we have some result and that it should now generate a new response based on that. But if you're working with a model that does not support that, you can always manually update the chat history as I did it here. And that's actually a great transition, because speaking of manually updating stuff, I mentioned before that when using Ollama, there are certain models that support tools like Qwen. And then there are models like Gemma that don't do that. There is no tools label here. But we can still try making Gemma work with tools, because Google actually got a nice documentation page where they tell you that Gemma can call functions. You just have to manually instruct it. And for that, it's important to understand that this nice little tools parameter, which we're sending to the Ollama API here, in the end is just a convenience feature offered by Ollama for certain models that have been fine-tuned to support tool use out of the box in a very convenient way. But this is actually not necessarily the only way of exposing tools to models, because in the end, and that's really important to keep in mind, you're interacting with token generators. And in the end, you just need them to generate tokens that describe a tool use. You can do that in a very easy way through officially supported features like this tools parameter for models that have been fine-tuned to look for a certain input. But alternatively, you could also try another approach. So now I'll store my tools description in a tools variable. And of course, we could pass that now to tools. But let's now say, instead of using the Quen model, we're now using the Gemma 3 12 billion parameters model like this. And again, this is a model that does not support tools in the Ollama world, so it will probably not work with that tools parameter. Actually, we can give it a try and see whether it does work. Maybe it does. I haven't tried it before. So let's see. What's the weather in Munich? Let's see. Okay, it fails. Probably because I'm setting tools here. Let's try without, just to make sure I haven't messed up anything else. What's the weather in Munich? Yeah, so now it's not failing. Instead, it's probably generating some text that it can't tell me the weather, or it's hallucinating. But it can't know today's weather because it has no access to that information. So let's see what we get. Yeah, it's outputting some weather here. But as you can see, it's some outdated weather. Probably maybe the last day for the training data that was used for training the Gemma models. I don't know. So it's clearly not today's weather. And it can't know today's weather. And setting that tools parameter doesn't work for that model. However, as I mentioned, we can still try making it work. Because what Google tells us in their documentation for the Gemma models is that we can just define some tools, and the exact shape is up to you. It should just be some structured shape that's descriptive and easy to parse and understand in the end. And then you send an augmented prompt to Gemma. A prompt that could look like this. So this is now a prompt suggested by Google, not a prompt you have to use like this, but a suggested prompt. So now we're telling Gemma in this prompt that it has access to functions. If you decide to invoke any of these functions, you must put it in a certain format, which we expect. You should not include any other text in the response. And then we have our tool, our function definition. And then we have the user prompt. So we augment the user prompt with an extra description of available tools. And in the end, that's probably the same thing that happens when you set the tools parameter for models that support it. They just have been, I guess, behind the scenes, Ollama sets some special tokens, and models that support it are looking for these tokens. So the tool definition and the prompt injection is taken care of for you for models that support it, but now we'll do it manually. So what I'll do here is I will take my let me see. I am updating my chat history here. So I will actually, I guess, update the user prompt here, or I inject a new message into the chat history. I think that's what I'll try here. So before sending a request, I'll append a message here. And I make it of role user. And now the message here will be a manually crafted prompt that tries to, please go away, cursor, that tries to describe the tools. So essentially what's also recommended here by Google. Oh, sometimes cursor is really annoying with its completions. Okay, so this is now the prompt I took from Google's documentation, where I tell the model that it has access to functions. Then here I want to have my tool definitions. So actually here I will inject tools, however, converted to JSON to convert it from a list of dictionaries to some text, to a string. And then here, I want to have my user prompt. Or actually, the user prompt is already part of the chat history. So instead, I could say, with that in mind, revisit the chat history and request a tool call if needed, provide a response to the user's original question otherwise. So we could try setting up a prompt like this. And with that, we manually inject information about available tools, and we ask the model to return a response in this format if it wants to call a tool. And actually, I'm not happy with that format, so I'll change it because the Google documentation also tells us that we can request a response in any format we want. So here I want to get some JSON data, let's say. So I'll tell the model, cursor, I don't want an autocompletion. I tell the model that I want to get back an object or some JSON that has this shape. I want to get the name of the function it wants to call and information about the parameters. And again, it's your prompt. You can try describing the tool use in any way you want. You just have to test whether it works with the model. And I don't know either if it will work here. We'll just give it a try. And I have double curly braces here because I'm in a F string, so I escape the curly brace, which would allow me to inject stuff into that string by using double curly braces, because I want the curly brace as a character here to just describe that I want to get back some JSON output that has this shape if the model decides to call a tool. Okay. So then we'll get back our output, and I'll print that output for now. And for now, I'll not do anything else. I'll comment out all that code because it wouldn't work right now anyways. I just want to see whether it generally works. So now I can try running this and say, what's the weather in Munich, and see if it does request a call for that tool, for that get weather tool. Let's see whether that's happening. So what do we get back? We get back, that's looking good. That's looking good. The content we got back is a list of dictionaries where every dictionary has a name key with the name of the function and a parameters key, which contains a dictionary with all the parameters it would provide to that function. And again, keep in mind, that is now a regular response by the model. That's just text here in the end. It is a string, but it is a string that contains the definition of a function call because we asked it to provide this kind of value. Now, technically here, it provided a list of dictionaries instead of just a dictionary, but we just have to handle that. So we got our message, which is output message, right? We're in that message. And now I want to check that content, the message content. And I want to check if well, we want to try parsing that. So tool calls is JSON loads content. Now, this will fail if this isn't valid JSON, but we'll handle this later. For now, let's assume it is. Then I want to check if that is a list. So I want to check if that is a list. And if it is a list, I want to access the first dictionary. If it is a dictionary right away, I don't need to extract the first element. So we can use some cursor here and say, check if tool calls is a list. If it is, access the first element. So thereafter, tool calls should be a dictionary that has a name key and a parameters key. So then again, we have the tool name and the tool args. And now we can bring back our old code here. And for now, I'll comment out this if check here, because now we will assume it's always a tool call and will handle the case that it isn't in a second. And I will actually also update the history manually thereafter, since we're doing everything manually here, so why not that? And I will return this message content here, though it will probably crash anyways, but let's see. So we're getting our name, we're getting the parameters. I print that information for debugging purposes. Actually, that should also be tool call, not tool calls. Makes a bit more sense, I guess. So technically, I can also change this code here like that. Print this. And then still check which tool should be called. And it's not arguments, it's parameters. And it's not inside of a function. Instead, now it's inside of, well, actually, I should, before I changed it all, before I changed it all, I want to git commit so that we save that old code that worked with Qwen. Or actually, you know what? I'll just keep that commented out code here. So it's parameters here. I'll name it tool call, not tool calls. And then I'll just duplicate that code so that we have both the code that worked with Qwen and now the code that will hopefully work here. So I'll just duplicate this code here. And let's also grab that tool result here. And then I will, as I said, update this chat history manually here. With the results of that tool call. So now we're doing that based on that tool call or that tool result, which we hopefully get due to our manual description of the available tools. So that should now update the chat history. What we're not prepared to handle here is the scenario that we don't want to use a tool, but instead we were ready to generate the final answer. So essentially, if JSON loads fails, we know that we don't have valid JSON data. So we don't have something like this. And that is a clear indication that we don't want to use a tool, or that the large language model doesn't want to use a tool, or that it provided some invalid output. So actually what we can do is we can use a try block here and try getting that tool call. And actually, I guess we can therefore move all that code into that try block here for now. So we try doing that. And if we make it to the end here, then I want to return generate response again. Until we fail, so until we got some content in there that's not a valid description of a tool call, which means we probably have a proper response. And in that case, I want to return output message content, because then we have the actual text content that should be output. Or I just output the content. I'm already extracting it here. So I just output the content here. Now, this is definitely not the most elegant way of handling it. It has a couple of problems. For example, if we would request data in JSON format. That's not a tool description, but something we want. We would accidentally try to handle this as a tool call here, which is definitely not what we want. But for this demo, to keep things fairly simple, I'll go with this approach for now. So let's see whether this now works. In theory, we're now describing the tools to Gemma, and we're looking for output by Gemma that has the shape we described to it, either a dictionary or a list of dictionaries. Either way, we try to get access to the tool call description. We then extract the name and parameters. We execute our tool code. We enrich the chat history. And then we generate a new response based on that updated chat history, which does include the tool call. And then the model could either call more tools, or it returns some text, the final response, for example. In that case, this will fail. We will hopefully make it in here, and then we just return that text. That's the idea here. So let's see whether that works. So if I just say hi, it should not call a tool. It should fail to parse the result as JSON, and therefore it should make it into this else block and return just the text content, which it does, as it seems. So now let's ask, what's the weather in Munich? So now it called that tool and looks like it got the results correctly, because the text it generated is definitely based on the data I provided for Munich. So in my dummy weather data, where is it? Here, right? Temperature, humidity, wind speed, it's all in there. So that seemed to work. If I ask something like, what's 30 degrees Celsius in Fahrenheit, it should call that convert temperature tool, hopefully. Okay, now it just says I want to call. Why is this not working? Let me restart. What's 30 degrees Celsius in Fahrenheit? Okay, so one problem we can see here is that it looks like it's not consistently returning the intent in the defined format here. So we can verify that by printing that content before we do anything with it, before we try parsing it as JSON. So if I now run this again and I say, what's 30 degrees Celsius in Fahrenheit? Let's see what the raw content, yeah, the problem is the raw content now is a list with a dictionary that has a function key in it. And then in that function key, we have the dictionary that contains the actual data we need for the tool call. That's not what I'm expecting though, and that's also not what I'm requesting. I'm requesting to directly get a dictionary that's not nested in some other dictionary with a function key. And because we got the wrong format, our code here didn't work as intended, because when we were looking for the name of the tool to be called, we didn't find that key because it was all wrapped in that other nested dictionary. That's one problem you of course have if you're working with models that have not been fine-tuned for that tool use, because the fine-tuned models very likely have special tokens they're looking for to find the tool definitions, and there might be extra steps involved when they generate responses to ensure that they definitely generate responses that have a certain structure that's always the same when it comes to describing tool use, because they have been fine-tuned on extra data that practiced the tool use, so to say. This model, the Gemma model, has not been fine-tuned for that, as it seems, and that's why it does return a description of the tool use that's not always the same, and that does not always follow our instructions here. It's also worth mentioning that this is not the most capable Gemma model. I just haven't downloaded the biggest one. So therefore, that is one problem we have here. Now what we could do, or what we could try, is of course we could do some prompt engineering to make it more likely that we get this format. So we could say, if you want to use a tool, make sure to use exactly the format to describe the use of the tool using exactly the format shown above. As a reminder, here it is. You could try stuff like this, right? Don't return any extra text. Don't return an object in any different shape. We could do something like this. We could try whether that works. So if I ask what's 30 degrees Celsius in Fahrenheit, now it worked. If that worked because I got lucky or because I did some extra prompt engineering, I don't know. Either way, it's important to understand that it's you that defines this prompt. You're defining this prompt, so you control how likely it is for the model to output a proper tool request or not. Now, .cold, thank you so much for the amazing feedback. Means a lot to me. Thank you so much for the kind words. Really amazing. And Volkov, maybe it makes sense to put tool instruction once into system message. Definitely. So I was going to cover this because, of course, what we're doing here at the moment is we're appending this to the history for every cycle. So whenever we got a tool response and we're calling generate response again, we're injecting this message again into the chat history. Now, that might not be entirely bad because it keeps it in the recent memory of the large language model, so to say. But we could definitely consider setting this up once as a system message instead. So instead of doing this here, whenever we generate a new response, we could alternatively go to the place where we start this chat and add it once as a system message. Whoops, like this. And now, of course, we would not spam the chat with these instructions all the time, because in a longer chat, we would have a bunch of these instructions if we did it as I showed you before. And that, of course, means that a lot of extra tokens are in the context window, which does not cost you money if we're talking about a local model, but which can still degrade performance and also is just unnecessary. So we could try this. The danger is that the model maybe forgets about this the longer your chat history gets. It's hard to tell. But we can definitely try this. And now if I say, what's the temperature in Munich? It calls get weather and it outputs this. I don't know why it outputs it twice, but yeah, it's the correct value. And now I could, of course, also ask, what's that in Fahrenheit? So we have a chat, right? So that should be part of the chat history. The problem just is that now it outputs some text. I don't know. By the way, I know why it outputs this twice, because I have this extra print statement here. This one. So that's not a bug. But now the problem is that, again, it did not output the tool request in the format we specified, but instead it made up some format here. It just gives me the parameters and it describes the tool name as plain text. And that's not ideal because I can't parse this here. Now maybe that is because it's a system message. So of course we could see if that works a bit better if I go back to the approach I had before, where I inject this for every message I send to the model. So let's try it like this, though there is always also some luck involved. So even if it does work now, that's no guarantee that it will always work. But now if I ask, what's the temperature in Munich? Let's see if that works again. It does. What's that in Fahrenheit? Yeah, now this time it works. You would definitely have to do more testing though to be confident that it works all the time. Now, one other thing you can do though to increase your chances is when you test this and you see that it maybe has like 3 or 4 different ways of describing the intended tool use, you can of course also just check for these different formats in your code to make your code more flexible. And of course, you can also not do any of that and just use a model that has built-in tool support, like the Qwen 3 model, and then use that tools parameter, which we used before. And that will make it much more likely that it will work as intended. Still, not necessarily 100% guaranteed. We're still dealing with a token generator there, so it can still hallucinate. But it's definitely more likely because the model has been fine-tuned for tool use. The Gemma model here hasn't, which is why we have to manually tell it how to use tools. And as you see, that introduces some potential problems. Still, it's pretty interesting, at least for me, to see how tool use in theory works. That it's not some magic going on. The tool isn't, the large language model isn't magically writing code and generating code on your behalf. Instead, it's just requesting tools you defined, and it's then you in your code that actually executes the tool code. I find that really important to understand and see, and this hopefully shows how that works. So even though the OpenAI example at the beginning did not work, unfortunately, I think this local stuff is even more interesting, and the OpenAI part would have worked in the same way in the end, right? OpenAI, their SDK, their API, they support tool use. They have models that are fine-tuned for tool use. So this code here should work, even though I was not able to test it. This code here, as you see, does work, and it works for both models that have built-in tool support and models that don't, but those are then a bit more unreliable, as you saw here with the Gemma model. Okay, so that was a lot. Hello, are we gonna see a fully fledged Nest.js course anytime soon? I know you guys have a 1-hour video on YouTube, but I was wondering if you have something bigger planned for it. Unfortunately not. Nest.js is a great framework, but I haven't worked with it for the last couple of years. So yeah, I got no course planned on that, sorry. Sorry. But yeah, that's actually it for today. I think that's a good point to stop. The start was a bit bumpy with OpenAI, but we got there, and I hope it was helpful. As I mentioned, I will upload it to YouTube tomorrow, so you can rewatch it or watch it if you joined a bit later, or skip ahead if you want to skip the bumpy OpenAI part. And yeah, if you found it interesting, I'd be, of course, happy to welcome you back in future streams. I typically stream every Thursday, and all the best to you. Bye.